Hello, you're watching Nested High School Computer Science. I'm Sam. Let's get started. Today we're talking about Quicksort, one of the fastest sorting algorithms out there. Quicksort uses the idea of divide and conquer, which we saw earlier with binary search. Here's how it works. You choose a pivot, typically the middle item, and then from that pivot you compare it to the other items. Items that are larger than the pivot go on one side, and the other items go on the other side. And now you've got your list in two halves. You do that again to each half, and then again to each half recursively until you end up with a completely sorted list. For the demo for this, I'm not going to use sortingalgorithms.com. I find the animation a bit confusing. Instead, we'll be using the Computer Science Field Guide, an online textbook developed here in New Zealand by myself and a few others. It's an excellent resource for teachers and students. I highly recommend you check it out if you haven't. The link will be in the show notes. So here we are using the sorting boxes activity from the Computer Science Field Guide. This was developed by Jack Morgan at the University of Canterbury. Here we have a set of scales, and when you compare two items, the arrow will point to the heaviest. Here we know the green is lighter than the blue, so let's put the blue on the right of the green. Now we'll move on to the next item. This one is lighter than the green, so we'll put it on the other side. I've left a wee gap for where the green will go. Here I've moved over the gap, and I've moved the gap again. We now know the green is about here, and these items are all lighter than the green, and these items are all heavier than the green. Now, we can just do this again on the two halves we have left. They're not exact halves, which gives an indication about how careful you have to be when choosing your pivot. I just chose it random. I'm going to move on to this other side. We know that this blue one and this orange one are both heavier than this green one. So let's compare the two and find out which order they go in. We can tell that the blue is the heaviest. So at this stage, we know it's now the heaviest one in the game. For a sanity check, we can just double check that these are in fact in order. We see now that they are in order. Since I know they're in order, I'll put them in their final positions. Now, we've got 5 items left. Let's do the same process again. I'll start with this purple coloured one and compare the rest of the items to it. I'll speed up the rest of the activity because after this, it becomes pretty mechanical. I'm just following the same idea. Halve the list, do it again. Here we are with our sorted list. Take note of the number of comparisons, 17 for 8 items. So that was a demo of Quicksort. Once again, I recommend you check out the Computer Science Field Guide. It may be geared towards the New Zealand curriculum for now, but it covers a lot of topics from computer science, and it's the book on which the series is based. If you're a teacher watching this, you should be able to slot the topics into your curriculum for your country quite easily. So, a summary about Quicksort. Obviously, it's much faster than selection and insertion sort. It's O n log n. And once again, it uses divide and conquer. Proof about n log n with the numbers. If we did insertion and selection sort with the same 8 boxes, it would take about 64 comparisons. I just did it in 17, but theoretically it would take about 24 comparisons on average. As you can see, it's a lot faster than selection and insertion sort. Once again, we see divide and conquer outdo the simple and naive algorithms. This has been Quicksort from Nested. Please like and subscribe, and if you have any questions, please leave them in the comments. Thanks for watching. We'll see you next time on Nested.